Hello everyone, welcome to EduFarm. Please like, share the video and subscribe to our channel and hit the bell icon to get further notification. So students, welcome again. Today we will discuss about another important chapter of central nervous system, that is sedative hypnotics. In this video, we are going to talk about their pharmacology and chemistry of the drugs. So let's begin. Now, what is sedatives? Sedatives are the drugs that suppress excitement and calms the subject without inducing sleep. That is, after administration of sedatives, drowsiness is produced. Then what is hypnotic drug? Hypnotics are the drug that induces or maintains sleep similar to normal arousable sleep. Hypnotic can produce sleep, but sedative produce only dizziness. But in higher doses of sedatives, they can act as hypnotic. So both are CNS depressants. Sedatives are comparatively slower acting than hypnotics, but the duration of action of sedatives are longer than hypnotics. Then, coming to the classification of sedative hypnotic drug, based on their chemical nature, drugs are categorized into 4 classes. That is benzodiazepines, barbiturates, non-benzodiazepine and the other drugs. Again, benzodiazepines are categorized according to their pharmacological action, which are hypnotic, anxiolytic and then anticonvulsant. Diazepam, flurazepam, nitrazepam, alprazolam, lorazepam, temazepam and triazolam are the hypnotic drug, and diazepam, chlordiazepoxide, oxazepam, lorazepam, alprazolam, clonazepam comes under anxiolytic group. And then clonazepam, clobazam, diazepam and lorazepam comes under the anticonvulsant group. Similarly, the barbiturates are classified according to their duration of action, and these are long-acting drug, which is phenobarbital, and then short-acting butobarbital and pentobarbital, and then ultra-short-acting, which is thiopental and methotrexate. Then non-benzodiazepine drug. Zopiclone, esopiclone, zolpidem, zaleplon, etizolam are the non-benzodiazepine drug. And here are the drugs, that is triclophos, melatonin, ramelteon and civorexant are the other drugs. Benzodiazepines and barbiturates are the important drugs, and in this video we are discuss about them. So, how these drugs act in the body? That is, what is the mechanism of action of this drug? Benzodiazepine act on midbrain, which maintain wakefulness, and also act on the limbic system, which control the thought and mental functions relatively. They act by enhancing presynaptic or postsynaptic inhibition through a specific benzodiazepine receptor, which is an integral part of GABA A receptor chloride channel complex. Benzodiazepine act in the alpha-gamma subunits of the receptor interface, carries the benzodiazepine binding site. Here you can see, in this site benzodiazepine act. After the administration, the drug enhances the GABA-induced hyperpolarization due to influx of chloride ions. That is, intracellular concentration of chloride ion increases and then sedative action takes place. Then the uses of benzodiazepine drug. Mostly, these drugs are used in the treatment of insomnia, that is hypnotic and anxiolytic, and also used in the convulsant as anticonvulsant drug. Then, adverse effect of the drug. Dizziness, vertigo, ataxia, disorientation, amnesia, sleepwalking are the adverse effect of these drugs. Then, drug interaction. If CNS depressant is administered with alcohol or alcoholic drug, then synergistic effect is happen, which leading to excessive impairment. Then coming to the barbiturates. Barbiturates act primarily at the GABA benzodiazepine receptor chloride channel complex and potentiate GABAergic inhibition by lengthening the chloride channel opening. At high doses, barbiturates inhibit calcium ion dependent release of neurotransmitters and depress glutamate-induced neuronal depolarization through AMPA receptors and depress voltage-sensitive sodium and potassium channel. For the detail, you can go through our previous video of general anesthetics where we already discussed about the barbiturates and their mechanism of action. Link is given in the description box below. Then coming to the uses of barbiturates. Phenobarbital is used in the epilepsy and thiopental and methoxytone is used in the anesthesia. Now, let's discuss about the chemistry of the sedative hypnotics. First, take a look at the classification according to their chemical nature, that is the basic ring structure present in the drugs. And the classifications are barbiturates and benzodiazepines, which I already mentioned in the earlier slide, and then pyrazolopyrimidine derivative, that is zaleplon, imidazole pyrimidine derivative, zolpidem, chloral derivatives, that is chloral hydrate, alcohol derivatives, ethchloroxinol, and then piperidine-dione derivatives, that is glutathione. Then, as you can see, this is the structure of barbituric acid. I am trying to explain easily through this table where you can see the substitution at R5 and R5' position here, and through this you can understand the substitution of hydrocarbon groups or alkyl functional group denote the structure of different barbiturates derivative. Now let's move on to the ACR of barbiturates. As you all know, the ACR, that is structure-activity relationship, is the relationship between chemical structure of a molecule and its biological activity. So this is important for us. Now let's see. This is the basic structure of barbiturates, and the criteria for sedative hypnotic properties. Barbituric acid itself does not produce any sedative hypnotic properties, but substitution at position 1 and 5 and 5' position with organic alkyl or aryl possesses sedative hypnotic properties. To show these properties, barbituric acid derivative must have a definite lipid-water coefficient value. And then the 5-5' distribution. And then coming to the first point, that is chain length. Total number of carbon of the substituent group at 5 position must be in between 4 to 10 to show sedative hypnotic properties. Small alkyl group resists tissue oxidation and shows long duration of action. And then branching. Branching of alkyl group increases lipophilic character and the compound becomes more potent. Then unsaturation. Unsaturation in the substitution increases the lipophilic character of the compound, and as a result, the compound easily cross the blood-brain barrier and exhibit quick onset of action. Then introduction of halogen group to alkyl chain. It increases the lipophilic character and compounds become more potent. Introduction of polar group, that is OH, COOH, NH2, increases the lipophilic character of the drugs. And then substitution of alkyl group at N1 position. The alkyl substitution at N1 increases the lipophilic character of the compound. So greater the chain length of alkyl group, more potent the drug. Then replacement of oxygen atom of keto group with sulfur atom. 2,4,6 trisubstituted thiobarbituric acid becomes low lipophilic character. That is why it does not show any sedative hypnotic properties. Then coming to the chemistry of benzodiazepine. Here the basic ring structure of benzodiazepine derivative is this benzodiazepine ring, which contains a benzene ring and a cyclohexane ring with nitrogen atom. Now benzodiazepine derivatives contains this structure: 5-phenyl 2H 1,4-benzodiazepine 2,1. So you can see in this table the substitution can take place in position 3, that is 3rd carbon, and then 7th carbon and 2' position of the phenyl ring. Substitution in this position denotes the structure of these drugs. That is the benzodiazepine derivatives diazepam, oxazepam, nitrazepam, and then lorazepam and clonazepam. You can see the structure. Temazepam also comes under this group. Then the ACR of benzodiazepine derivative. This is the ring structure of benzodiazepine derivative. Coming to the ring A, that is this ring. The minimum requirement for binding with benzodiazepine receptor of 1,4-benzodiazepine derivatives include aromatic or heteroaromatic ring, which is responsible for pi-pi stacking of aromatic amino acid residue of benzodiazepine receptor. Then attachment of electronegative group or atom at position 7 increases the hypnotic property. Then substitution at position 6, 8 and 9 decreases the sedative hypnotic activity. And then in the ring B, electron accepting group at position 2 is responsible for interaction with histidine residue of benzodiazepine receptor. Then substitution at position 3. Substitution with OH group at position 3 increases the anxiolytic property of the drug. Then coming to the ring C, where the phenyl ring at position 5 is not essential, that is, this phenyl ring that is denoted by C is not very much essential, but the presence of this phenyl ring helps in hydrophobic interaction with benzodiazepine receptor. Substitution at 2' position of the phenyl ring with electronegative atom increases the anxiolytic activity. So guys, that's all for today. See you in our next segment. Please like, share and comment below if you have any queries regarding this video or any other topic you may want to know about. Thank you for watching this.